We've talked about how Git builds up a chain of commits that record the history of the project. But how do we keep track of where we are in this chain? Or in other words, how do we switch between different versions of the same file? As we'll see in this video, this is where version control systems like Git really excel. I want to start with a motivational example. Many of you may have found yourself in a similar situation to this before. In this example, you are working on a file, let's say homework.docx, which is a Microsoft Word document. And for a while, you can get along just fine with a single copy of this file. But now, imagine that you want to make some experimental changes, but you also want to keep the previous version of the file for comparison. What do you do? Well, the obvious solution is to make a copy of the file. We'll give the new one a nice name, like Homework version 2, so that we remember which was which. Now we have two copies of the same file. Not too bad. But let's say that you need to do this again. Maybe you want to create a third copy that combines the best parts of Homework and Homework version 2. Okay, that's a third copy. And it's the final one, so we stick final onto the end of the name. Now I hope you're starting to see where this is going. We are starting to get a proliferation of files. And you might argue that 3 files is still not too bad. But maybe you get some additional unexpected feedback, and this gives you another copy of the file. So after incorporating those changes as well, you get another final version of the file. And this time, it really is final. I really mean it. Except, there's always something else you could improve. And so the nightmare begins. Now, you might argue that you know which version of the file you're working on. After all, you've been up to midnight trying to get the homework assignment finished, and that may well be true. But what about if you wanted to come back to this in 6 months, or a year? Would you remember what was happening, or which files had been derived from which? Even worse, imagine this was a collaborative project. Would the other members of the team be able to make sense of this mess? And would you be able to make sense of their messes? Fortunately, Git offers us a solution to this problem. We can use something called branches to track different versions of the same project. Along with commits, branches are one of the most important features of Git, so in this video we'll take a look at what they are and how they work. Let's say our project has just one commit, this green box E5X91N. Git creates a branch to keep track of where you are. It does this automatically when you start a new Git project, and by default it picks the name master for this first branch. What is this master branch? It is just a pointer, an arrow, to a particular commit. In our case, we only have one commit, and that is what master points to. This is really the key idea behind a branch. It's just a pointer to a particular commit. As a side note, I have put an asterisk, a star, in front of the name master to indicate that this is a branch that we are currently on. When we create more branches in a couple of slides' time, we will move this asterisk around to indicate which branch is active. Okay, let's imagine that we make some changes to the project and commit them. We get a new commit, 4OLS8G, that takes a snapshot of the project at this moment in time. Because we are on the master branch, Git automatically updates the branch to point at this new commit. We can also create new branches. When you create a new branch, it points to the same commit as the branch you were on before. So if we were on the master branch, which was pointing to 4OLS8G, and we create a new branch called branch 2, then this new branch also points to commit 4OLS8G. Note that we have also switched to the new branch here, and the asterisk has moved to branch 2 to denote this change. At this point in our project's life, we could switch back and forwards between the two branches, and the versions of the files would not change, because both branches are pointing to the same commit, and hence the same version of each of the project's files. However, what happens if we add a new commit while we are on branch 2? Well, we added a new commit to our chain, and the branch pointer updates to point to this. But because we are on branch 2 and not on the master branch, only the branch 2 pointer gets updated. The master branch stays pointing back at the second commit. Now, if we were to switch our project between branches, the files would be updated to the versions corresponding to each commit. We could switch back to the master branch, for example, and the files would go back to having the contents that they had at the time that the second commit was made. Let's imagine that while we are working on branch 2, another commit has appeared on the master branch. Perhaps it's been added by one of your collaborators. The master branch now advances to point to this new commit. So both branches now contain one extra commit. The files in each branch are different, and again, we can easily tell Git to switch back and forwards between the two branches, and it will update the project's files to their correct version. Now, at some point, we usually want to combine the different versions of the project that we have on different branches. To do that, the first thing we are going to do is to switch back to the master branch, and you can see the asterisk has moved to the master to reflect this. Then we just tell Git, please merge branch 2 into the branch that we're currently working on. And it does it for us. It figures out what were the changes that were made on each branch and how can it combine them. And then it creates a new commit, a type of commit called a merge commit that combines both branches. You'll note that a merge commit actually has 2 predecessor commits. The other nice thing is now both branches get updated to point to this new merged commit. This might seem a little like black magic, but it's not. For example, how does Git figure out how to combine 2 different commits? Let's take a look at how files actually get merged. Say we start with this one file, file A. Now file A has 3 lines whose contents are, very unimaginatively, line 1, line 2, and line 3. When we create a new branch, branch 2, it initially points to the same commit as branch 1, and so the contents of file A will be exactly the same, line 1, line 2, and line 3. But now imagine that we make a commit on each of these branches. We update file A differently on each branch. On branch 1, we replace the first line's contents with Bob Smith. On branch 2, we replace the third line's contents with my name. What does the combined file A look like after we have merged one of these branches into the other one? Well, during the merge process, Git goes through the file line by line and combines any changes that occurred since the 2 branches originally separated. After the merge, file A looks like this. Git has updated the first line with branch 1's changes, and the third line with the changes from branch 2. Easy, right? Well, you might have noticed a problem here. What happens if both branches edit the same line? Here's what I mean by that. This is what the top of an R Markdown file might look like. On line 1 you have some dashes to indicate the start of the header section. Line 2 holds the title of the document, and line 3 has the author's name. There might also be some stuff below this, but I'm just showing you these first 3 lines for simplicity. Again, the file's contents will be identical when the branch is first created, because both branches will point to the same commit. Now let's imagine that Bob Smith and I both edit the author line by adding our names. We each commit our change, so now the branches have diverged, and then I decide to merge the branches together. What will happen? This will happen. Git will stop midway through the merge and will give you a message that there is something called a merge conflict. A merge conflict arises when Git can't figure out how to combine one or more lines. It doesn't want to accidentally overwrite something important, so it stops. What it does is it marks these conflicting regions for us with something called conflict resolution markers. These conflict resolution markers are the inequality and equals signs that you see here. Remember that our conflicting lines were author equals Dominic White and author equals Bob Smith. Git begins the region with a sequence of opening less than signs, followed by one of the branch names, and then the conflicting line from that branch. In this case, that was my name. Then there are a line of equals signs. This separates branch 1's version from branch 2. Then we have the version of the line from branch 2, followed by greater than signs to signal the end of the conflicted region. So Git has modified the contents of file A so that it contains the contents of branch 1 and branch 2, as well as these conflict resolution markers. It is now your job as the programmer to open the file and replace this entire 5-line section with the version that you want to keep. Here's one solution. We could decide to say good riddance to Bob and delete all of his lines from the file entirely. Do you see how we have deleted everything except for the line from my branch? We also have to delete the conflict resolution markers. Now, while I personally am fine with this, Bob might be a little upset that we've deleted his name. So here's another option. We can replace the entire conflicted region with these 3 lines, which will keep both mine and Bob's names as authors. Notice that these 3 lines were not in either of the 2 original branches. We can replace a merge conflict with anything. And when we're done, don't forget to delete the conflict resolution markers so that Git knows that you've fixed the conflict.